Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about completing the square. All right, well, what is completing the square and why do we need completing the square? Let's back up a moment and talk about some definitions that we'll use as part of the process of completing the square. First is a perfect square trinomial. Well, we've talked about perfect squares before. We know perfect squares for just values or constants would be 4, 9, 16, 25, 36, 49, 64, and so on and so forth. 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25, 5 squared, 36, 6 squared, 49, 7 squared. A perfect square trinomial has 3 terms. So I have a trinomial. Tri stands for 3, nomial, name, or term. So I have 3 terms, the factors of which are the same number, or the factors of which are the same values. So, for example, x squared plus 4x plus 4 is a perfect square trinomial, the factors of which are x plus 2 and x plus 2. So it has the same factors. X squared minus 6x plus 9 is a perfect square trinomial. The factors of x squared minus 6x plus 9 are x minus 3 and x minus 3. Okay, so we know what a perfect square trinomial is now. Again, it's a quadratic, it has 3 terms, and the factors are the same values. So completing the square is a process of adding a term to an expression. We'll say it's x squared plus bx to make it a perfect square. So we're going to use some of our magic. We're going to add a c value in the end, and we're going to convert a trinomial, or a binomial in this case, to a perfect square trinomial. In some cases, it could be a trinomial that we're converting to a perfect square trinomial. But in any case, we're taking a trinomial or a binomial that's not a perfect square trinomial, and we're going to convert it into a perfect square trinomial. Well, what do I mean by x squared plus bx? It would look like something like this, just x squared plus 4x. And the value that I would add to it to make it a perfect square trinomial, as in the example above, would just be plus 4. And this plus 4 we call the c value, right? Because when we set this quadratic up in standard form, the standard form is ax squared plus bx plus c. So a is equal to 1, b is equal to 4, and c in this case is equal to 4 as well. All right, so let's talk about the process of completing the square. So the first thing that you want to do is you want to identify the a, b, and c values. Okay, in this case, the a value is going to be 2. So I write in here 2, the b value is going to be 4, and the c value is going to be negative 8. So if a is not 1, then we're going to divide a, b, and c by a. So we take a look at the example, a is not 1. So we need to divide a, b, and c by a. If a is 1, we're just going to continue to step 3. But in this case, a is not 1, it's 2. So we divide a, b, and c by 2, and we get just 1x squared, or x squared, plus 2x minus 4. Now we're going to write ax squared plus bx on the left-hand side of the equation and move c to the right-hand side of the equation. So what I'm going to do is I'm going to add 4 to both sides of the equation, and I end up with x squared plus 2x is equal to 4. So before I had x squared plus 2x minus 4 is equal to 0. Now I have x squared plus 2x is equal to positive 4. All right, now I'm going to figure out what the c value is in order to create a perfect square trinomial. And that c value is just going to be b over 2 squared. Okay, so in this case, 2 is my b value. I divide it by 2, and then I square that value, and I get 1. So I'm going to add 1 to both sides of the equation. Right? I can add 1 to both sides of the equation. I still take care of my what I call accounting. Because I've added 1 to the left-hand side and 1 to the right-hand side, the equations are still the same. All right, now the fifth step is to write the left-hand side as a squared binomial and simplify the right-hand side. So what the heck is a squared binomial? Well, we talked about trinomials. Trinomials have 3 terms. Binomials, binomial has 2 terms in the expression. So a squared binomial is a square of 2 terms, and here we have a squared binomial. So we're going to rewrite our expression as a squared binomial, and instead of writing x squared plus 2x plus 1, we write x plus 1 squared, which is the same thing, the same value. So now I have x squared plus x plus 1 squared is equal to 5, or 4 plus 1. Now I'm going to move on to step 6. I'm going to take the square root of both sides to remove or eliminate the squared binomial. And when I take the square root of a squared number, remember I have to add, in terms of my accounting, I have to add a plus or minus to the other side of the equation. So I end up with now x plus 1 is equal to plus or minus the square root of 5. After I take the square root of the squared number, I have x plus 1 is equal to plus or minus the square root of 5. Then I simply just subtract 1 from both sides, and I end up with a value for x. And that value is x is equal to plus or minus the square root of 5 minus 1. And that's my solution for x. So I tell my students if they want 50% credit, then they only put a positive here. If they want 100% credit, they're going to have to add both the plus and minus. So remember, when you take the square root of a squared number, you're going to have to add the plus or minus to the other side of the equation in order to account for the possibility of there being both a positive and negative solution to the value. All right, now we're going to talk about uses of completing the square. So in the beginning of the chapter, we talked about the different forms of quadratics. We talked about standard form, intercept form, and vertex form. And it was very easy to convert from vertex form to standard form. We just multiply the values out and rewrite it in standard form. Now we're learning how to create vertex form from standard form. So you want to be able to move back and forth between intercept, standard, and vertex form. And the process of completing the square is going to allow you to take a quadratic in standard form and convert it to vertex form. So here we have a quadratic in standard form, and we're going to rewrite it in vertex form. So the first thing you're going to do, step 1, is to write the original quadratic equation in standard form, and we've already done that. Y is equal to x squared minus 10x plus 22. Now we need to figure out the c value that makes the original quadratic a perfect square trinomial. And what we're going to do first is we're just going to remove, we're going to remove the positive 22 from the right-hand side of the equation by subtracting it from both sides. So now I end up with y minus 22 is equal to x squared minus 10x plus 22 minus 2, or plus 0. And step 3, I'm going to figure out what the c value is to make this x squared minus 10x, this binomial, into a perfect square trinomial. And I figure that is going to be b over 2 squared, or minus 10 over 2 squared, which is equal to 25. So then I add 25 back into the equation. And also, when I do that, I need to add it to the other side of the equation. So now I have y minus 22 plus 25 is equal to x squared minus 10x plus 25. Continuing on, step 4, I simplify. So now, instead of y plus 25 minus 22, I have y plus 23. And then I have also x squared minus 10x plus 25. Now I'm going to rewrite my perfect square trinomial as a squared binomial, and my squared binomial is going to be x minus 5 squared. And then I subtract 3 from both sides. Now I have y is equal to x minus 5 squared minus 3. The equation is now in vertex form. And if I recall correctly from the prior chapters in chapter 4, I now know that the vertex of this particular quadratic is going to be 5, 3.